Okay, we're in 5.2 dimensional analysis. In 5.1, we converted things like 3,700 millimeters into 12.1 feet, and we solved that using ratio tables. So we made conversions using ratio tables when they were multiple conversions. But this took up a lot of space. There's another solution technique that's much more compact and leads to the representation of conversions using equations. This new technique we're going to study in 5.2 is called dimensional analysis, and it's emphasized in all science classes. The basic idea is that we just like we cancel common factors in equivalent fractions. So if we had 15 over 20, that's the same as taking a factor out, making that 3 times 5 over 4 times 5. The 5's cancel, they reduce to 1, and I'm left with 3/4. So 15/20 is the same as 3/4. We're going to use this idea of canceling, only we're going to do it with units. But first, let's just review 5.1, the essentials of 5.1. So here's an example from 5.1. It's sort of a good summary of what we did. We used the ratio table here. And we're going to convert 3.75 kilograms, which, I'm sorry, is right here. Or let's make that 2.75. So we're going to convert 2.75 kilograms into grams and then into ounces. So you want to find out how many ounces there are in 2.75 kilograms. Now the way to read these tables is each row is an equivalency. So, and I put these on a number line right here, just to show you. So 1 kilogram is the same as 1,000 grams, and that's right here. 1 kilogram, 1,000 grams, right? And the other equivalency we have here is right here. 1 ounce is 28.35 grams. So with these two facts, this fact here and this fact here, notice things that line up vertically are equivalent, right? We're going to find these facts here. I can't directly find this fact, right? Because I don't have a conversion from kilograms to ounces. I just don't know what that is. The only conversion I have is kilograms to grams. Now let's watch. Here's the kilogram to grams right here. So that's one ratio. And here will be the second ratio, which makes a proportion. So I'm going to write that down, give some space, and write that down right here. So there is my proportion, right? Here's my known fact. 1 gram equals 1,000 kilograms. So there's my ratio. And the other ratio is I want to know 2.75 kilograms is how many grams. And the way I'm going to solve this is cross multiply and then divide. And you should be an expert at that now. But I'll put the answer in. And there's the cross multiplication, and there's the answer. So that would be 2750. So what we've shown is that 2.75 kilograms is 2,750 grams. Now just going down to our number line here. We get that. These are vertically lined up, meaning they're equivalent. Okay, so here's the last one I need to do. And the relationship that I have is right here. There's an equivalency. 28.35 grams is the same as 1 ounce. So 2750 grams is the same as X ounces. So you need to be able to set up a proportion, cross multiply, and divide. Now I would hit pause if I were you and see if you can do this. So there's our work. Cross multiply and then divide. 28.3, any number divided by itself is 1. 1 times X is X. And so this should be a technique that, this is really what you needed to learn for 5.1. So now I can put the 97 here. And here's a equivalency. So that can go down here. And indeed, 2.75 kilograms is the same as 2750 grams, which is the same as 97 ounces. So this was, I had to make a double conversion here. In 5.2, we don't have, we're going to make this a shortcut. Okay, we're going to do this one example, but there's a lot packed in here, right? So try to follow this. This is really the whole ball of wax. We're going to convert 3,700 millimeters into meters. Make that an R. Using dimensional analysis. All right, we start with the given quantity of 3,700 millimeters. We write it down here. And then multiply it by conversion factor. Now, the conversion factor is 1 meter equals 1,000 millimeters. And we turn it into a fraction. 1 meter over 1,000 millimeters. And that equals 1, because it's the same value, right? The numbers aren't the same, but the value's the same. So any number divided by itself, like 6 divided by 6, 7 divided by 7, is always 1. The only one that doesn't work for is 0. But 1 meter is the same as 1,000 millimeters. So I could flip it too and have it be equal to 1. So basically, I'm just taking this, multiplying it by 1, and what I'm doing is converting. Watch how this works. We can multiply this by this fraction, right? We're going to multiply 3,700 millimeters by this fraction. It's called a conversion factor, without changing the magnitude or size of the quantity. So I'm not going to change this magnitude. This is really, really like an equivalent fraction. Like taking 3/8 and multiplying it by 2 over 2. It's extraordinarily similar. So what happens here is that the units cancel. This is in the numerator. This is in the denominator. It's exactly like this. This is in the numerator. This is in the denominator. They cancel. So the millimeters cancel, and I just go ahead and multiply 3,700 times 1, and then 1,000. 3,700 divided by 1,000 is 3.7 meters. These have the same value. The only thing I did was change from millimeters to meters.